Today before from streaming from today before from today for today we are going to uh, do the revision of LeetCode problems that we have already solved before. So today we'll do the revision of 2-point problems. Okay, so let's first start with a valid palindrome. Okay? This is the same problem, like if the word or letter is palindrome, uh, if you spell it from backward or forward, it's still same. Okay, so a phrase, a palindrome, if after converting all the uppercase letter to the lowercase letter and removing all the non-alphabetic character, it reads the same forward and backward. So we can do it in two ways. Okay, so first way is to have a 2-point problem. 2 point. Let's first remove all the what do you call this change the application to lowercase, and then remove all the spaces and special characters. Okay, remove non-alphabetic characters. Okay, so remove all the non-alphabetic characters. After that, what we're gonna do is we're gonna get a 2-pointer. First pointer at the start of the array, and one at the end of the array. And while our start of the array index is less than our right pointer of the array, we keep on checking if our left is equal to right. Okay, so let's first start with so we have given a string. First let's start with uh, changing this string uppercase into lowercase. Okay, all we do, let's first loop through all the remove non-alphabetic. Okay, so to do this we need to do first loop through all the character. Okay, before that let's create a temp string. Okay, then the characters e yes. Okay, take if see that is alpha. How is alpha is the CC type. Okay, CC type we need is alpha. Okay, al num is al num. Okay, and we need to change it to the static cast it to unsigned int. Okay, so or we can do this. We can even do this. But let's do this. Okay, instead of doing this, let's do this to check if it is alphanumeric or not. Check if C is greater than or equal to A, and if C is less than or equal to G. It is all if this condition is true, it is already what you call in a lowercase. Okay, or the application in lowercase. So it's already in lowercase. All we need to do is add it to the temp string was equal to C. Okay, then again if or else if C is greater than or equal to capital A and less than or equal to capital G. All you need to do is first convert it into the lowercase. Okay, so dim. Sorry. So how can we convert it to the lowercase? So I think there is a function named lowercase to lowercase change to lower. Okay, there is a function named to lower. So this we have to cast it plus 32. Okay, plus 32 because uh, initially capital A is 65 and small is 32. Okay, so let's do plus 32. Let's do plus equal to 32. Then let's do 32. Then all we need to do is then what we need to do is C plus 1 32. Then we dim string plus equal to C. Okay. Then now we have all the we have changed all the uppercase to lowercase and remove all the special characters or non-alpha numerical characters. Okay. So now what we're going to do, we're going to create a two pointer. Okay. Let's create a pointer. Let's name it uh, point left. Okay. That will start with 0. Okay. Then pointer right. That will start with whatever string that size is -1. Okay. What length? I think it's length or size. Is it length? Let's do size, then see if size. Then all you need to do is that now that while our left is smaller than equal to PTR right. Okay. I need to check if PTR left equal PTR equal as PTR right. If our PTR left is equal to PTR right, we do nothing. Just continue. Or we, if it is not equal to, then we just return also. It's just return its size or the length. Or we will see. So if it false, it will false for every answer. Then why is that? Also, print string. Okay. We have the a man, a plan, a camel, Then okay, so we have converted it. So that's not the issue. While PTRL is less than or equal to PTR left. So there is a two cases, like if odd or even. Yeah. So let's start with let's say there is only three words. First we'll check, then second check, then third stop. Should work because let's say we have three let's say RR, then AA, then CC, then we do yeah CC, then we do EA. So not let's say if there was AA, then we have swapped. If there was middle, uh, odd and even. This should work. It's not equal to return. Let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. 21. So 21 we have even number. So what to do is keep on comparing till we go to the middle of let's say C. We'll see if C is equal to C. Then we increase it. Sorry, we have never increase or decrease the PTR. So PTR L plus plus PTR L sorry R minus minus. This is final. Testing or returning true. This is still we are returning false. So we end of the iteration we are increasing and decreasing and keep on comparing this. Is here. A and capital A. Sorry, I'm doing checking with the wrong. Instead of checking with temp string, I'm checking with a string. That's the issue. This also the minor problem of checking with the wrong. I mean this I'm getting true. 0 and P. So we have P. If we remove the alphanumeric character, so it is 0 and P, not O and P. It's 0 and P. So we remove 0, we just add P. And we check for P. Remove all non-alphanumeric characters. So we did remove all non-alphanumeric characters. Then we compare. And it reads the same forward and backward alphanumeric character, including the letters and numbers. Okay, including the numbers also. Sorry, I thought we do not have to do numbers. So if I C is equal to 0, greater than so c is greater than equal to 0 and c is less than equal to 9. Add it to that one. That means we need to read the problem properly. Did I just read half of the problem and then started the code? That's all. That's this. Okay, so this works. Okay, so let's write more of revision. Okay, let's see the previous solution for this problem. Okay, we are already doing this. We do this. Okay, so we do not changing anything. So we are not adding anything. So this similar problem. Okay, so we will have written continue so that we do not check if any of this problem, any of this above is true. We do not check it below. Okay, we could have done that, or we could have created a or we could have written else if else if else if. So if one of the true, one of them is true, we do not check the others. Okay, and that could also be the case. So that's not. Let's move on to the next problem. That is to sum. Second input array is sorted. Okay. Um, let's again read through the problem before solving. Okay. So given an one index array of integers numbers that is already sorted in a non-descending order. Find the two numbers such that they add up to a specific target number. Let those two numbers be numbers index I and the index I2, where I1 is less than or equal to index 1 and less than index 2 is less than or equal to number length. So both index 1 and 2 should be between 1 and number length. Okay. Return the indices of the two number index 1 and index 2 each incremented by 1. Okay, as an integer array index 1 and index 2 is of length 2. Okay, because we need to because the first index is 0 and then 1 then 2, so we need to add 1 to both. Okay, the tests are generated such that there is exactly one solution. You may not use the same element twice. Okay, your solution must use only constant extra expression. So it's already sorted. So we can what we're gonna do is we're gonna just have a 2 pointer, left pointer and right pointer. We're gonna check if we add the both. If we add both, do we get target? If we get greater than target, what we do is we decrease the left. Okay, left pointer. Okay, if you get greater than the target, sorry, if you get greater than the target, we decrease the left. If you get smaller than target, we increase the left. Okay, left pointer. If you get greater than the target, we decrease the right pointer. If you get smaller than the target, we increase the left pointer. Okay, so let's implement this. Okay, let's create a 2 pointer, left pointer. That will be our 0. So our right pointer, that will be our size of number. Okay, so once what you do is keep on checking while again if our right pointer has passed the left pointer. Okay, so while our left pointer is smaller than or equal to right pointer, No, not smaller than, equal to, just smaller than, because we need two indices, not same indices. Okay. So while our PTR left is smaller than PTR right. So we check if our, we check, we int sum of int that would be what's PTR left, what's PTR right. Okay. Now what we do is simply check if sum is equal to target, then what you do simply t return return result. Okay. The picture of result. Okay. What you do is simply result to pull whatever of PTR left plus 1, because the index start at 0. So okay. Then result dot push back PTR right plus 1. Okay. Then we break the loop. Okay. Like, let's say if, let's say our number constraint. Okay. So what is the constraint? So our length will be always greater than 2. Okay. So num can be anything. Number I can be negative or positive, and target can also be negative or positive. This plus this. If we do left plus right, sum of -1 and 0 is -1. So, we always add left plus right. Otherwise, we always add left plus right. If we add right plus left, this will have been different. If it's 0 plus -1, that will be our -1. If it is plus, we do not need to worry about that. Okay. So we break it. Okay. We return the result. Okay. Else what we do is simply, if it is not equal to target, we check if our sum is greater than target. If our sum is greater than target, what we do is right, we decrease it by 1. Okay. Else, if our sum is smaller than target, we left do plus plus. So the sum it up. Then you plus 1. This problem is also solved. Let's write. Yeah. Okay. So our revision. Okay. Pointer using hash method. Okay. This is to use two pointer. Another option is to use a hash method. If we do the solution of this problem, this is also similar. Everything is same. So yeah, do this. If it is, if our sum is greater than 0, minus star. It's similar thing. You can do this to that solution. If we add this minus the target, we should get 0. If it is greater than 0, we do this, or we could have just second if we greater than target. Similar, everything is just similar to this one. If it is equal to 0, we just break it, and whatever our PTR left and PTR right, we are just sending it like this. But in this problem, we created an vector, and we post the element to the vector, and then we return. But in this, we have simplified it more. So we have added the both, divide minus the target. So if the numbers left plus number right is equal to target, we'll get 0. If it is greater than 0, we are sure that whatever our sum number left plus number right is greater than target. So we uh, decrease the pointer left. If it is smaller than target, we decrease it. Else we are sure that sum is 0. So sum is 0, we break. Once we break, we decrease the both. So both are the proper solution. You can implement any of this solution anywhere. Now let's move on to the next problem. That is three-sum problem. For the three-sum problem, we also do the similar thing. Let's first go through the question. Okay. So given an integer array, nums return all the triplets num I, num j, and num k such that I is not equal to j, I is not equal to k, and j is not equal to k. So num I plus num j plus num k equal 0. So all of these equal to 0. So this minus 1, minus 2, and 2. The solution sheet must not contain a duplicate triplet. Okay. To solve this problem, we have to we can solve it in two ways. Okay. Let's first sort this number. Okay. Once we have sort this number, what we do is then we do this. Okay. Let's first sort. Let's see the constant. Okay. So it will always greater than 3, and number of very simply we first sort it. Then we take one of let's start from the first index. We take the first index as a target, and then from the first index next element to the last element, what we do is we check if any two adding, we get the first index. So that means if we add 2, we get the first index, or if we add any 2 and subtract this, we get 0. By adding all of these 3, we get 0. Adding all of it from target left and right. Okay. So first we sort, which we have sorted. What we can do is make sure we do not have a non-duplicate. Whatever we can create a set. See if we have already sorted, we can be. So let's first create a vector of int result. Then we create int check. Okay, we check if it already exists. Yeah? that we do not add it twice. Okay? So what we'll do, we'll start from the first element of number. Okay? Getting back number 7. Int I get set left position. Okay, 0 while I is less than while I target is less than if we have at last third index we have checked these two. So if we move to this index, we do not have any two elements to check. So while our nums dot is minus 1 will be this, minus 2 will be this, minus 3. So while minus 1 minus 2, well, this is smaller than 2. Once get this, we will not check it. Target plus that's our target. What it is, implement basic left and right pointer index. So the left, that will be our target, plus 1, and then int right, that will always be nums 1. Okay, simply while again we do not check the same element twice, so we do not do like 1 2 and 2. So while our ptr left is less than ptr right, what we do is simply int sum, that is, let's say, left to right. So tr target plus ptr left plus ptr right if all the sums is equal to 0. So let's say if sums is greater than 0, like the last problem, what you do is simply if it is greater than 0, ptr right minus minus. Okay? If sum is less than 0, ptr is possible, else break. Okay, once you break this one, we are here again. What do you need to return? We need to return the elements. Not to like we not return index, we return elements. So what we return? Target, num left and num right. Okay, simply what we do is on break, before break, let's add it here. Okay? Check if already exists. Okay, check all of this. Open, wait, It's here, if it's like if send this say if find if p already if does not exist. Check if it does not exist. What we do is check that search p and result that usf push back and we return set of set of int check set to be a default constructor. Take declaring and calling to an implicit delete default constructor of one split. So it is deleted with vectors what is the repetition as let us on the PCR. Yes. So if there is no left of this visitors of limit cannot do this. The default CPU library does not provide a hash function for the vector segment. It's not provided. Create it again. We remove this, this. What to do is let's wait. In this iteration, if let's say if we have -1 twice, if comes the target 1 for 0 uh, for 0 then we can under -1 target is it is equal to nums target plus 1 are the same. We'll do it right up. Let's not do anything. Let's just return this. We get twice element 2 times instead of getting also. Is hot it. This is without hot it. 2 minus 4 something. Is hot it. We must set it to implement it a little different way. And under this, we need to check all the possible. Let's say start. We check all this. We cannot implement this. We need to do plus minus all the time. That's why we sort it. If our tile and tile plus 1 is tile plus 1 or minus 1. 0 minus 1. So 0 and 1. Okay, we get 0. And for 0, we get 1 plus for 0, we get 1. Then this minus 2, then we get 0. So we check target is not equal to 0. Target is not equal to 0. Target is not equal to 0. And target so is not equal to 0. So we don't get similar to the answer choice. 0, 0 minus 1, 1. This is the same. Minus 1, 1, and 0. Then we get these two elements similar. Hmm. So this one we get, let's say, last thought that is there is 1, 0, sorry, minus 4, minus 1, minus 1, 0, 1, 1, 0. So 0, what it is, so we take the target of 0, then we check 1 and 2. So it's not so this here. So we have to take taking from more. So we find it or still keep on checking for more so that we can get, okay, so we do not get a question. That is, if we add equal minus n, that's also we do this. So we get, now we get the same target taken for all the solution. Same target keep on checking for more. Similar to the Krishna problem, if we do not want to sort it, we can implement that problem. We check all the possible answers, not just the first one. But if we do not, if we let's say you can see this is also sorted order. This is also in sorted order. So we need to sort. That's for sure. This is the no. This is not in the sorted order. Why is not this in sorted order? Left target target. So we should not even get this one. We have already sorted. If we have sorted this one, once we reach one, we check only for element of front. This is our target. We are not sorting it properly. Is sort function. This should work. Then go to the pen, then we print it. Put each step 0, 1, 2. Okay. For -4 we check. For this we check. Again for -1 we check. So for -1 we check. For -1 we check. -1 this. So this plus this, that is greater than -1 plus -2, that is -1. So increase this one. And for 0 plus 2, so we decrease this one. So 1 and 0. 1 and 0. Put this -1 as a target. So should get this and this. -1 plus 2, that is -1 plus 2, that is 1. We get 1 is greater than 0. We reduce this one. So again we get, sorry, so -1 -1, that is 0 plus 2. So we are getting greater than 0. This plus this plus this, getting greater than 0. We need to get so reduce this one. Now -1 plus -1 plus this this plus this will be 0 plus 1. This plus this, which is 0 plus 1. So again there's nothing. Then again we use this plus this. So we get the greater than 0. We reduce this to again 1. And this -1 1 -1 -1, that is 0 plus 0, that is 0. So at the end we get 0. We add it. Adding it to the target, we are adding target first, then left, then right. You are pushing it to the distance. This should go. Target plus 5. If it is greater than, there is no way this question. Better will be this. That's the issue. First, we should get this one. The first of the index -1, -1, and 0. But we still get it in different order. -1, -1, 0. -1, -1, -1. That is -1, -1, that is -2. So -2 and 2. Target plus 1. Right for the target this plus this plus this. Target is -1. So -1 is -1 is -1 is that will first they will get 2 plus 2, so that will be 0. So also will get 0. We add it. What's the issue? Our target is not equal to 0. Target is equal 0. Resources. So let's explain this. Beating this one. First we start from -4 as a target, then we check this two. Currently doing this. Sorry, what's the issue here is target. Adding target instead of nums to target. Sorry, nums target, not target. Target, not index. That's the issue. Element at the target. So now we are getting what we want. Just we are getting extra. So to prevent an extra, what we do is simple inhibition. So we whatever we have written at before in the first iteration, that was a python. All we needed to do was check this one. Okay. Instead of target, we need to do nums plus target, or we need to create a variable named target. What we instead of the target index, that will be target. That is target index. Okay. So again, we are getting twice for this zero. We if the last index for this we do not do, then for this we check if this if it is if target index is not zero, this previous is zero, so we should skip. We should continue. But this we checked it. But once we check it for this one, not to check it for this one, then we not check it for this one, then we do not need to check it for this one. We not need to check it for this one. Target continue. Target index is not zero, so this is not zero at this check and nums whatever the value at the target index is equal to the value at the previous target index. We do not continue with the question which is doing over here, but why is not working over here? First we do it for zero, then we do this, then they get this first 0 0 0. At the second iteration we do this. Why? So, if this is not equal to zero, then and current index element and previous index element is equal, we continue. Okay? So for zero, we continue for all the zeros, we should continue. 0 and 5. Okay. 0, 1, 2, 3, 4, 5. That is 1. Oh, 1. So first 0 index we check. Then with other index 5 we check. So other index 5, what do you do? 0, 1, 2, 3, 4, 1, 2, 3, 4, 5. What of 5? That is 1. For 1 we check. So this plus this. 1 plus 1 plus 2, that is 4. It run only once. Do this. Once we find an element for that one, we just click. First index, first zero, this one. Or three times the similar. This one, or do this one. For zero, we check this plus this. Then we get the answers. Then again, we increase this one, we get this one again. And here, we this duplicate. Second iteration and the second iteration with a particular element. With previous condition attempt, let's see how we have solved this problem. Result again, put a greater than 0 and this is this. Zero one, this is what it is. We again. So right, we start target. So we know we need to this it, we can push the result of pushback, pushback, then we skip the duplicates. Okay, we need to implement things to skip the duplicate. So here is our left pointer is less than our right pointer, and pointer is equal to plus next pointer. So we need to skip the duplicates. Also to skip the duplicates, what I do is simply let's our pointer is over here, then our pointer is over here till left pointer. Let's move the left pointer till we pass all the elements of the same index, same element, and for the right we just pass all the elements of simply do pass. First we add the element, Then again, there is a chance that left and right, after increasing and decreasing, we get the similar one. So what it is, do not get the similar one. What is simply do, while ptr is less than ptr right, because we need to do this for this particular condition, okay? And check if our num ptr left is equal our nums ptr left plus 1 plus 1. Why do we do left plus 1? Because uh, we do left plus 1 because we can be sure that our left will never be at the end. Will never be at the end, so this will never give an index out of element. Okay, so that means simply do ptr while our ptr is less than again ptr right. I want to check if nums ptr right is equal or p nums ptr minus 1. So this will never be 0. Okay, ptr right will never be 0. Oh, okay, because of this condition, ptr right will never be 0. So if this is never ptr, it will never be 0 till this one. And this it will never be 0 because it will go at last of ptr left. Ptr left is say first iteration. Let's say we have ptr. Uh, this will be greater than 1, 0 plus 1 because of this one. Okay? Index is you can be sure for these two condition will never get index out of bound. So ptr ptr sorry, use that to move on to the next problem. Before moving on to the next problem, let's one that let's do on the study one more. We have implemented everything. Everything was fine. Just we need to can implement everything. Just need to be sure do this. uh, check if our next if we are checking the same target element uh, for the same target index, and then previous target index element are similar, we need to skip so that we do not check the same for the two twice. Okay. Then once we got one of the target, we need to skip all the possible similar elements from the left and right so that we do not get duplicates. So yeah, so we skip all the similar element from the left and right. Okay, similar element from the left and right. So to remember this, to skip the similar element from the left and right, and this again, these two things. Fission problem. That container with most water. Okay. Now let's again go through the problem before solving the problem. Okay. So let's you are given an integer array height of length, and there is an n vertical lines drawn drawn such that the two endpoint of ith line are I and 0. Two endpoints of the ith line are I to 0 and ith. Find two lines that together with an x-axis form a container such such that the container contains the most water. Okay, return the maximum amount of water content. So simply, all you need to do for this specific problem is create a left pointer and right pointer. Find an area for that specific pointer with a smaller point. Once the smaller point we get, what we do is we have calculated for this specific smaller point, we increase that point. Okay. So what we do, let's get a left pointer and right pointer. We calculate the amount of water this can contain. So this is 1, and whatever the last index, let's say 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8 minus 0. 8 minus 0 into 8 minus 0, that is 8. 8 into 1, so 1. So this area will be 1. So once we get this one, whatever the smaller point is, we if this one, if left pointer is smaller, we increase the left pointer. If right is smaller, we decrease the right pointer. Okay? That's all we do. Change the smaller pointer. Okay, so let's do if int ptr left pointer, that will be 0. Int p right pointer, that is ch size so on. Okay, then while our left is less than ptr right. We calculate the area, and let's first calculate the what's called length, not length, width. Right. T is width, and that will be ptr minus. So our breadth is this this element index minus this element. So this is breadth, and height is length. Okay. So this minus ptr. Okay. Int for length, what it is, mean of, what is the mean of, so height of ptr left of ptr right. Okay. Whichever is smaller, that is our that one. Then we calculate area. Area is equal to length into okay, result. Okay, result area. Here, okay. We check if equals to result area of area result area. If our current area is greater, we just do nothing. If our recently calculated area is greater, we change that result area to that. Okay. Now, once we have all of these, we need to change the left pointer and right pointer. To do this, we need to see which one is smaller. If it's to height PTR left, we are already calculating this one over here. Okay. Whichever the minimum is. Which is to height PTR right. So in implementation, we implement this in as a ternary operator, so that and in a way that we do not even need to calculate this one. Let's see the proper solution. Then we try to optimize or reduce the size of the code. If our PTR left is smaller, what we do is left plus plus. It's- it's not. If our left is sorry, if our left is smaller than right, if it is not smaller than we exactly. Sorry, now we return result. So this one, it's not it. Before let's do one more thing. So, then remain is like int length. If length is done, this do this. Our length is the height. It's the height to our left smaller than is the height. PTR height is is the height. Is the height. PTR left plus plus. Before submitting within this is post post increment. Okay, post increment. Right. This is smaller. Still height. This post increment and the breadth. always decrease the right and increase the left one. This also works. So division model. So now let's go through the previous solution. How did we implement the previous solution? Again, well, our right is recommend. So okay, we have implemented like this again. And breadth. Then again we have calculated this twice. This time we have even simplified this one to even smaller. Figure the area, whatever the max area is, we use the max function. This time we calculate this one and leave it on the solution. So actually, now let's move on to the next problem. That is trapping rainwater. So for this problem, this is the hard problem. So we need to let's first let's go to the problem. Okay. So given an non-negative integer representing an elevation map where the width of each bar is 1. Compute how much water it can trap after rain. Okay, so how much water it can trap after rain. So this is given out to the the above elevation. So how much water it can trap. So that is a way to calculate this one. Okay, first we calculate it for all the water it can trap on the left side. Then we calculate all the water that it can trap on the right side. Was it this problem or different problem? That's one second. This one, what we don't need to do is calculate the water. So what we do is let's open the paint for a second. Lock. So what we do is simply start from here. Okay. Then what we check how much water it can trap on the left side of it. So we'll start from here, and both are index here. For the left side of it, it can trap water on the left side. Then we what we do is this one. Is this one? Okay. Left smallest. Please left pointer to here. So this cannot trap any water. So we whichever the smallest, we increase this one. Let's see how much water this can trap on the left side. So this will be this one. This much. Then again, what you do is we can be sure if there is a higher point, we cannot trap any water any more water on the left side. So what we do is we move this pointer over here. Okay, move this pointer over here, left pointer over here. Then again we do right pointer over here. We check how much water we can trap on this side. So we cannot trap any water on this side because our right is smaller than left. So we increase the right to here. We do right to here. Again we check how much water can we trap out to this side. So no water can be trapped. We do this side. I check how much water can be trapped on this side. No water, so we move on to this side. But while we are increasing right, if it is non-zero, whatever this element is, we decrease it from the area. So let's say we have area. When we start from here, we point up to here. So can we store any water on this side? Yeah, from the right? No, we cannot. So our still our area is 0. And then we subtract it 0, whatever the left is. So we'll get 0. Then we point up to here. So now we have answer as 1. Then what we do? We move R to here. So here, can we add any water up to this side? So we cannot. So we whatever this index element is, that is 1. So we will get again. We'll get it as a 0. Then again up to here, can we add any water on the right left side? We cannot. So whatever this height is, so this height is 0. So minus 0, we get 0. Then we point up to here. Once we move up to here, again we check if we can store any water on the right side. So to store any water, the left should be smaller than the right. So this is not smaller than the right. We do not do anything. We just move on. So again we move up to here. We check if our left is greater than if our right is greater than our left. Okay, it's greater than. Calculate this one. So now we have -1. So with this we calculate. So for this right minus left, so the 2. That is right minus left. What is the 1, 2, 3, 4? So 0, 1, 2, 2 minus 2, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. 6 minus 2, that is 4. So 4 into 4 into 2. 4 into 2, that will be 4 into 2, that is 8. And we do this, we'll get 7. Okay, get 7. 1, 2, 3, 2, 3, 4, 5, 6. 2, 1, 2, 3, 2. This is the index 0, 1, 2, 3, 5, 6. 6 minus 2, that is 4. But we do not need 4 because we do not trap any water on this, or this will trap in the middle. 6 minus 4 minus 1. So we do not touch anything. 3 into 2, this is 5. 5, 5, 2, 3, 4, 5, 6. 2, 3, 6. 2 into 3, that is 6. 6 minus 1, that we will get over here 6. Now we have 6. 1, 2, 3, 4, 5. We get 6, that we get 5. Because already we had -1. So -1 plus 6, that is 5. Then we can move on to this one. Then we get a larger one. We change it to that. This one will be left. This one is right. Again, can we add any water? No, we cannot add one water. So we subtract it. So what we do is 5 minus this one. Minus this 2, 3. And again move up to here. Can we touch any water over here? Cannot touch any water over on the left side. We cannot touch any other water on the left side. So we do this 3 minus 1, that is this one. 2, now we have 2. Then again from this we will do 0. This will have -1. Left to right. This was 5. So we have a 5 water from the left to right. Same similar thing from left to right. Left to right, we start from 0. So and this. calculate if it's not a present. There is no gap in between. So this one is this plus 0, we get nothing. Then we calculate this, calculate this 0, then 5 plus 1. The max is 0, max. This one, let's try to implement this one. How much water we can get. Int is area. Water. Calculate from left to right, right to left. So the variable is left to point. PTR left, that is 0, then PTR right, that is equal to 6. That is also PTR 0. This PTR right is less than is this one. So from the left, so let's take it from the left, right. So this so PTR right is greater than our PTR left. We calculate it. Here PTR if our PTR right is greater than 60 height. 60 height. This condition is true. What to do? What breath will be? Zero. GTS length. That will be whatever word. PTR right R right minus 1 minus PTR left. Okay. So for this index, we get this one, we get 0. So this is for this variable smaller, will be if PTR right is greater than PTR left, then only sure that this condition is true. We get this. So that PTR left would not equal to to height. If it is if PTR right is greater than PTR left, we do this. For this index, so nothing. For this index, nothing. Then we do for this index. We already did this. This condition is true, but then what you do is whatever PTR left will be PTR right. Area would be left CTH. And trap water. So if it will not this will it is smaller than it's greater than this. Otherwise, you will just so this PTR is less than what it is. It is more than trap water. Trap water with trap water. Trap water. Trap water. It is greater than what will with for this one. Yeah, plus max. Select methods from left to right. How much water can we track from left to right? How much water we simply done, done. Now we need to calculate the left, calculate from right to left. So let's firstly see if we get 5 for this one. Should get problem we are getting 2 whatever we get electron. This subtract this for this specific for this to this. Subtract it for this one. So continue. Subtract it again. 5 for the left to right. Now, this change to the right pointer, left pointer, right pointer, and left pointer. Instead of doing this for the right pointer, we will do this for the left pointer. Change it here. Start on PTR, right pointer. That will be CPI is to height, size minus PTR this right pointer. Left pointer will also be start from PTR right minus 1, while this is greater than, since PTR is greater than 0, let's get PTR left. So now we'll start from here. Now what it is, check if our this start from here. So check if our PTR left is greater than Yes. Yeah. Right. Zero. So we get zero for data player. This area what it simply does BTR right. Next one. So yeah, that is fine. This is over time. So let us get now instead of doing this next tab, right. Zero instead of zero. No, this will be this yeah, tab on the right side. Once whatever you have trapped from the right side, now it will go out. Once we have trapped from the left side. Tab, side, side, zero. What will be trapped from the left side. Water will be trapped from the when you move from left to right, then how much trap water will be trapped when you move from right to left. Then get total water. Is expected to be zero. Expected to be zero. So for this from right to left, this is zero. This is equal to so less than less than equal to, but for this we need to do less than. If we do both for less than or equal to, this will again give us 2, that then we'll get 4. That's it. See, if I do get also less than or equal to, then I do, we'll get 4 as for this specific problem. That will be wrong. Okay, so we get 4 instead of 2. So we need to do only one side. So we got the solution, but I think this is to calculate the solution. We calculate from first all the from the right, then we calculate all the from the left. But I think there is a great solution for this one. Okay. So how long did it take us? 1 minute. This. So, I think there is a better solution for this problem. Right? Okay. 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 We have done a similar thing. We have also done a similar thing over here closer, but in this we have use the vectors from the left or from the right. Right, then but we have changed the same. We have done similar thing, but we have changed a few specific uh, way of doing this thing. Okay, but we have done similar thing. Right? Let's go to this solution. See how can we implement this one. So we have max left, max right, then mean from the left right. So we are also calculating the similar thing, max left, max right. So like whatever we did over here, but instead of storing it, then calculating and using a formula, specific formula like this mean of left and right, and doing all of this, just calculated it like this. Okay, water is trapped on the right, water trapped on the left. So max left, max right, mean of max left. So max left, max right. So in 12 minus 1 for each I is equal to 0, while I is less than size, it is our size I plus plus. So what you do, calculate the max right. So what max right, that push max right, the first we push 0, for left also we push 0. Then we calculate height of size minus 1, size minus I, size minus I, size minus I for the right. Okay, is if it is greater than max current hour max. So we do height size minus I. Then again for the left, for check if our the current height is greater than our max height, we do max our height, not our height. Similar thing, we have implemented the similar thing. What we are doing is simply what we are doing is pushing left for the first iteration. What we do, push the 0 0 0 0 0 to the for the left and right. Okay, push 0 0. Then we check if our current size minus I, if it is greater than our max R. So max R is currently 0. Is our is 0 greater than 0? No. If our if our last index is greater than 0, if it is, so what it is, max R, we change it to the last index element. Okay, last index height. Then again we change it to the first index height. Next iteration we check, we keep on seeing finding the maximum at that particular index. Then we next iteration we push both of those things. Then again we check if for the next current index, that is size minus 2, size minus 2 is greater than our max. If it is greater than max, we put it. If it is not, we just leave it as what is the max. So whatever the maximum from the left, the maximum from the right. So what we're doing is starting from here. So first for this 0, for this whatever the maximum is from the left. So what is the maximum for this? What is the maximum for this? Um, this. Then we push this one. For this one, what is the maximum? This. For this, what is the maximum? This. For what is the maximum? This. For all this index, we put all of this. Then for this, put what is the for this? What is the maximum on the left side? Nothing. For this, what is the maximum on the left side? That is this one. For what is the maximum on this one? So once we calculate the maximum for the both side, we calculate the mean. So what we do is calculate then we calculate the mean. What is the minimum from the left and right? Last index of this one and maximum of the left. Whatever this is, that is m. Then we push that to the minimum. Then we calculate the minimum from the left and the right. What is the minimum at a particular index? Once we get the minimum of the particular index, what we will loop through the minimum, that is size. What is the minimum minus height? What is the minimum of that index minus that index height? Calculate it t, and then if t is greater than 0, if t is greater than or equal to 0, what is it? Result is equal to t plus. So this is another way of implementing the simple problem. So for what are we doing is simply for this part, calculating the max, okay, max right, max left. For this, what is the maximum for maximum element? This one. So nothing. So we do 0. What is the maximum? That's 1. What is the maximum? That is 1. For this, what is the maximum? That is 2. What is this maximum? 2. For what is the maximum? That is 2. What is the maximum for this? This is 2. What is the maximum for this? That is 3. Then what is the maximum? Then 3. Then what is the maximum? Then 3. What is the maximum? Then with 3. Then we calculate the max left, max right. So for this, what is the maximum right element? That is 0. For this, what is the maximum right? That is 1. For this, what is 2? For this, again 2. For this, again 2. For this, we have 3. 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 Then we have this. Okay. Then for this particular, then we'll go through this. Okay. For the first and this last, whichever the minimum is, we calculate this one. For 0. Then I can check this. This, what is the minimum? 1. For this and this, what is the minimum? 1. For this and this, what is the minimum? 1. For this, what is the minimum? That is 2. This, what is the minimum? That is 2. What for this and this, what is the minimum? That is 2. For this and this, what is the minimum? 2. For this, what is the minimum? 3. For it again. Keep on getting 3, 3 and 3 and 3. So whatever this is. Now what you calculate for this particular index, what is the area? What much water these can store? So whatever the height of this is, so whatever the minimum is, so minimum 0. So 0 minus whatever the height is, that is 2. So how much water this can store? So if we get less than, if we get greater than 0 or 0, that will give us how much water this element can store. Right? So for this, this is 1. So 0 minus 1 will get a minus. So this cannot store any water. So at that this index we calculate how much water at this index we can store. We have 0. Height is 0. So 1 minus 0. This can store 1. So 1. How much water this can store? Again, what is the height? 2. So what is the minimum? So 1. 1 minus 2. So we get negative. So this cannot store any water. For this one, again we will calculate 1. So that is how much water at this index we can store. Should be 2. So 2 minus 1, 1. So this can store 1 water. So we'll get plus 1. Again for this index, we'll have 2, 0. So 2 minus 0, that is 2 minus 0, that is 2. This can store 2 water. Okay. So how much water at any index we can store? To calculate that, first we calculate the minimum from the left, so maximum from the left, maximum from the right, then get the minimum and minimum from the left and right. And then we calculate how much water it can store. For that, we whatever the minimum minus whatever the index is, that much water it can store. We have completed all the 2-point problem today for the revision. Let's move on to the next problem. Once again, for this best time to buy and sell stock. So, so best price to buy and stock price. So for this one, let's do the revision for sliding window problem. We'll do the revision later. Okay. The next sliding window problems revision will be done next Saturday. Okay. Saturday we'll do the revision for this one. Then another then we'll do the revision. Okay. See you for today.